Right, so the rest of section 1.4 is going to be on composition of functions. And so there's some new notation that you may or may not have seen, maybe on the ACT, but I don't think you've seen it in a previous math class. But for composition, you can see this little circle right there that means composition, or you can have parentheses. But both of these are read f of g of x. All right, and it kind of means the same thing that we've talked about function notation before, like f of 2. It means the x becomes 2. The difference is here, the x becomes a whole different function. All right, so there's two ways you can think about it. You can think about it as running the g function through the f function. Or you can think of substitute the g function in for x in the f function. So however you want to think about it, whatever you're doing, whatever f is doing to x, you have to do that to g. Okay? It's a little different. All right, so let's look at this with numbers, and then we'll get to some that are a little bit more complicated with expressions. So for example 1, we have f of x is x squared minus x, g of x is 3x plus 2. And what we're going to do is find f of g of 1. And so just like always, when you guys have worked with order of operation, you would start inside the parentheses. So we're going to start off and find g of 1. So I'm going to leave that f alone out there, and I'll just take my 1 and I'll put it in for the x. All right, so that's what you would do to find g of 1. All right, and then that's going to be 3 plus 2, or 5. Okay. And then just like always, if we want to find f of 5, we'll just take 5, put it in for the x's. So 25 minus 5, or 20. So that's doing a composition of functions, one function inside of another function. We will also do another one here. So we're going to do B. B asks us to find g of f of 3. So we're going to start with f of 3. So I'll let the g just kind of hang out. F of 3 means I'll take 3, and I'm going to put it here, and I'm going to put it here. So 3 squared minus 3. Okay, so 9 minus 3 is going to be 6. Okay, and then g of 6, like always, we take 6 there into the g function. 18 plus 2 is 20. Now, that was a complete coincidence that both of those ended up being 20. That was not planned in any way. It just happened. It's fine. It could have been any number. But that's compositions. Okay, now we're going to do a composition with a table. Now, I love doing these. I'm going to try to go slow enough that you can follow, not mark things up too bad. But we're going to do the same thing. We're going to start on the inside. All right, so I'm going to let that f hang out, and then we're going to find g of 8. So g of 8 means go to where x is 8, find the value on g. So that would be 4. All right, and then f of 4 is go to where x is 4, find the value on f, and it is also 4 in this case. All right, let's do B. So we're doing g of f of 5. So let's start with f of 5. So when x is 5, f is 0. So now I want to find g of 0. When x is 0, g is 9. All right. Let's go to f of 4. So we'll start with f of 4. When x is 4, f is also 4. And then we just end up doing that again. F of 4 is going to be 4. Right. And then g of 6. So we'll start with g of 6. When x is 6, g is 7. Okay. And then when x is 7, g is 3. Okay, we can also do compositions with graphs, which is what we'll do on the next one. Again, so we're starting on the inside. So g of 3. So we go to the g graph. When x is 3, g is 4. Okay. And then it just tells us to find f of 4. F of 4 is going to be 0. Right, this one, we'll start with f of 1. In the f function, when x is 1, the function is 3. Right, and then g of 3, when x is 3, the function is 4. F of 5. So on the f function, when x is 5, f is 1. And then we're staying with f, so when x is 1, f is 3. All right, g of 0. On the g function, when x is 0, g is 2. And then g of 2, when x is 2, g is 0. All right, so now we're going to hold off talking about the domain to the next lesson, but when you find the domain of the composition, you look through all your work. You can't just look at the answers. What happens inside of the composition matters when you're finding the domain. We'll talk more about that tomorrow. So today, we're just going to do those first two parts of this example 4 and 5, where we do the composition. And then we'll talk about the domain in the next lesson. All right, so f of g of x. So that means we're going to take the whole g of x function, which is x squared minus 3, and we're going to put it in for x in the f function. So everything that f is doing to x, we're going to do that same exact thing to x squared minus 3. So I'm still going to have the square root, but instead of under the square root being x plus 4, we're going to replace the x with x squared minus 3, and then we still have the plus 4. Okay. And then I would simplify if I can underneath the square root, and all I can really do is just add negative 3 and 4, and that's it. That's all we can do. We're done at this point. That is what the value of the composition is. Lots and lots of people want to take the square root of the x squared in that one. I promise you can't. That addition messes that up. And you could try it, like plugging in numbers for x and see and do the square root. It will not work. Like if you wanted to say that you do the square root of each and get x plus 1, that's wrong. If it had been this, the square root of that is x plus 1, but x squared plus 1 is x plus 1 quantity squared is x squared plus 2x plus 1. It is not that. All right, so you are done at that moment. All right, we're going to do it the other way now, where we do g of f of x. So in the g function, we're going to put in the f, which is the square root of x plus 4. So in g, everything we're doing to x, we're going to do to the square root of x plus 4, which means we're going to square it. And then we're going to subtract 3 from it. Now when you square that whole square root, you are just left with x plus 4. And then when you subtract 3 from it, you get x plus 1. And that's your composition. Okay, let's look at example 5. Same thing, we're going to find f of g of x and g of f of x. So we're going to take what g is, which is weird, 7 over x plus 6, and we're going to put it in to the f function, which means I still have 1 over, but in the place of x, I'm going to write that weird function, and then I'm subtracting 6 from it. Okay. All right, so anytime you have a fraction inside of a fraction, if that's by itself in the denominator, so this is like one big fraction, what we can do is just do the reciprocal. So that's the same as 1 times the reciprocal of that, or just x over 7. Okay, so that's your composition. And then let's look at g of f of x. So g of f of x is 1 over x minus 6. So in the place of x, down here in this little denominator, I'm going to put that whole thing. So 7 is still in the numerator, and then 1 over x minus 6 in the denominator. I know that's weird. I hate the way that looks, so let's fix it. So we're just going to take 7 and then multiply by the reciprocal of that. So we get 7x minus 36. And we have a lot to talk about with the domain tomorrow with both of these problems. All right, so the assignment for day 1 is on page 60. I want you to do 2 through 20 even, and then 22 through 25.